This is the 7th video for Unit 6. In the last video, I just ran out of time and wasn't able to get to problems talking about finding all solutions. So let's do a few of those. And I want to talk about both those where you find the exact values and you're not using your calculator, as well as those where you give a decimal approximation and you're using your calculator. Okay, so let's talk about the first type. So the directions would be something like find all solutions. All right, so let's start with an example. How about, let's do sine of x equals negative root 2 over 2. Okay, well, I usually think between 0 and 2 pi first, and sine is negative in quadrants 3 and 4, where y is negative. And when you see that root 2, you're going to think reference angle pi over 4. So the quadrant 3 angle, that when I take the sine, I get negative root 2 over 2, would be 5 pi over 4. And the quadrant 4 angle would be 7 pi over 4. Now, given I want all solutions, you think, okay, every time I go around the circle, in other words, all coterminal angles to 5 pi over 4 and 7 pi over 4 will also have that same ratio when I take the sine. So I'm going to say plus 2k pi. And remember, k is contained in the set of integers. Okay, so that was a sine. Let's do a problem with cosine. So how about cosine x equals root 3 over 2. Okay, so first we want to think of that reference angle. When I take the cosine, do I get root 3 over 2? And that's going to be pi over 6, and I should say in the directions I should have said give answers in terms of radians. And cosine's positive in quadrants 1 and 4. So there's two ways you could think about this. So you could, just like we did with sine, do separate and say, okay, quadrant 1, the angle I'm talking about when I take the cosine, that I get the ratio root 3 over 2, that's going to be pi over 6. And quadrant 4, that would be, if I think between 0 and 2 pi, that would be 11 pi over 6. And then, same as sine, I could say plus 2k pi plus 2k pi, where k is contained in the set of integers. But I find it easier, the further along you get in math, sometimes, I don't want to say shortcuts, but you want to be concise and not write more than you have to. So I might say, instead of two separate lines here, the quadrant, there's no reason you have to give your first these angles here between 0 and 2 pi. You just want to reflect all angles, that when you take the cosine, you get root 3 over 2. So instead of saying pi over 6 plus 2k pi and 11 pi over 6 plus 2k pi, for quadrant 4, I could think negative pi over 6, because that's a quadrant 4 angle. So I tend to just write one statement with cosine. I say plus or minus, in this case, pi over 6 plus 2k pi. The positive plus 2k pi of pi over 6 is giving you all the quadrant 1 angles, and the negative plus 2k pi is giving you all the quadrant 4 angles. So that's the nice thing about cosine. You can write that with one statement there. Okay, let's do one with tangent. Let's say tangent of x being negative 1. All right, again, this is tangent is 1 and negative 1 when the reference angle is pi over 4. And tangent is negative in quadrants 2 and 4. But remember, with tangent, the period is pi, so all I need to do here is to get all angles, because if I think of quadrant 3 here, the angle when I take quadrant 2, the angle when I take the tangent, which gives me negative 1, would be 3 pi over 4. And then the quadrant 3, excuse me, quadrant 4 angle would be 7 pi over 4, and so on. Well, notice these two differ by 4 pi over 4 or pi. So I really just need to, there's no reason like sine to write two statements here. And same with cosine, I can just write 3 pi over 4 plus 2k pi. Is that the only way to write it? No, I could have said, instead, I could have said negative pi over 4 plus 2k pi. Negative pi over 4 being a negative quadrant 4 angle. Oh, yeah, not 2k pi. Sorry. Jeez, not 2k pi. Backtrack there. K pi. Again, every pi, as I just talked about, but just got into automatic mode by saying 2k pi there. Sorry about that. Plus k pi. So tangent, again, and you don't need both of these. You can just use one of these. So really it's sine and its reciprocal function cosecant that you do need those two different statements. But with cosine and tangent, you can write get all angles by just using one statement. Let's do something that an angle or a ratio that doesn't result in angles falling within a quadrant. What if we have something like this? What if I said find all solutions sine x equaling 0? Well, when is sine 0? Sine is 0 when we're on the x-axis. So think about 0, pi, 2 pi, 3 pi, 4 pi. So I can just say every k pi. So that is an instance where I just need one statement there. I don't need more than one. Okay, so that's finding all solutions when we're giving exact answers. Let's talk about it when we need to use our calculators. All right, so what about, let's, again, we're going to do a calculator. So finding all solutions again. And let's have sine x equals negative 2/3. Okay, and that's not a ratio that corresponds to one of our special angles there. So then what I need to do here is I'm going to go to my calculator. Just make sure you go to mode and have radians highlighted. And this is going to, once we do inverse trig, it's going to make a little bit more sense why we're getting what we're getting in our calculator. But if you put in inverse sine, that little sine superscript -1 above the sine function, so you do second sine and put in negative 2/3, you get the following. You get negative I'm going to just round to the, well, yeah, I'll just round to the hundredths, negative 0.73. Okay, well, it's helpful to know, if I just putting my axes here, that pi over 2 is about 1.57. Pi, we know, is 3.14. 3 pi over 2 is about 4.7. So negative 0.73 is going to be a negative quadrant 4 angle. And, okay, so if I want to, and I'm going to give all solutions here. So what is the reference angle? Well, if this is negative 0.73, the reference angle is just the positive version of that. So that can be helpful. Most people find that helpful. The reference angle is 0.73. Now, you can use, if you want to find, so sine is negative in quadrants 3 and quadrant 4. We just got a quadrant 4 angle that got spit out, negative 0.73, so we certainly can use that. So we're going to say for the quadrant 4 is negative 0.73 plus 2k pi. But for quadrant 3, well, how am I going to get that? Well, the quadrant 3 angle I can get by saying, okay, pi plus my reference angle. That will get me into quadrant 3. So let's just do that quickly on my calculator. So plus pi, so about 3.87. And then, of course, you're going to say plus 2k pi. So again, when you're right, it'll make more sense in why our calculator is giving us the angle it is in the particular quadrant when we talk about the inverse trig function specifically. But it's good to know where that's landing, so then you can use that, what quadrant that's landing in. So you can use that to find the reference angle and then find any quadrant you want. All right, let's do another. Let's do cosine, or one with cosine. So cosine of x equals, let's do negative 1/3. All right, so again, let's move to our calculator here and do inverse cosine negative 1/3. And I get 1.91, which is a quadrant 2 angle. And cosine is negative in quadrant 2 and quadrant 3. And remember the nice thing about cosine, I can simply get the quadrant 3 angle by doing negative 1.91. That will land in quadrant 3. So to get all solutions here, I can just say plus or minus 1.91 plus 2k pi, which is kind of nice. Okay, and let's do one more type of problem here. Again, where we're using our calculator, but this time, let me, instead of giving me all solutions, what if I ask you just to give solutions between 0 and 2 pi? All right, so let's open up all right, if I open up a new page here. So again, it's solve for x in 0 to 2 pi. Okay, so give all solutions in 0 to 2 pi. And let's start with tangent this time. Let's do a tangent problem. Tan x equals negative 3, for example. All right, doesn't correspond to any of our special angles. So we're going to make sure you're in radian mode. And in your calculator, you do inverse tan of negative 3. And you get negative 1.25. And that's a negative quadrant 4 angle. So negative 1.25. So that's not going to be one of our answers because we need it to be between 0 and 2 pi, but we can use this. The reference angle is the positive version of this. So the reference angle is the distance between the terminal side and closest x-axis. So a reference angle is always a positive acute angle. So the reference angle is 1.25. And how can I use this to find the angles between 0 and 2 pi? When I take the tangent, I get negative 3. Well, if I'm talking about getting a negative ratio, I want angles that are in quadrants 2 and quadrants 4. Now, you may say to yourself, well, negative 1.25 is in quadrant 4. I agree, but it's not between 0 and 2 pi. So let's first do the quadrant 2 angle. To get that angle, I'm going to do pi minus the reference angle. And I'll do that in a second. To get the quadrant 4 angle, I'm going to get 2 pi minus this reference angle. And once you recognize that, it's just a matter of putting it in your calculator. So pi minus 1.25. And use the actual pi button, which is right above that, upper arrow above the division sign. Okay, so 1.89, which indeed is in the second quadrant. And then I'm going to do 2 pi minus 1.25. And that is going to be 5.03, which is definitely in the fourth quadrant. Okay, so those are the two solutions between 0 and 2 pi. Let's do, let's mix it up. Let's do secant. Secant of x equals, let's do negative 3 again. All right, well, there is no secant button on your calculator, and there's also no inverse secant button. So you've got to change it to the corresponding reciprocal function. And what I mean is this means that cosine x equals negative 1/3. And now I can, on my calculator, do cosine inverse negative 1/3. And let's see what that gets us. So inverse cosine negative 1/3. That is getting us 1.91, which is in quadrant 2, which is something I do want. Because when I'm looking for secant being negative, or cosine also being negative, I want quadrants 2 and quadrants 3. Well, the question is, how can I get the quadrant 3 angle? Negative 1.91 is a quadrant 3, but it's not between 0 and 2 pi. The easiest sometimes people think is, okay, well, if 1.91 is the quadrant 2 angle, what's the reference angle? So the reference angle is going to be pi minus 1.91. So let's see about what that is. So if I do pi minus 1.91, that gives me 1.23. And now, once you have the reference angle, you can find any angle in any quadrant you want. So to find the quadrant 3 angle, where secant is negative, I'm going to do pi plus that reference angle we just found. So 1.23 plus pi is going to give me 4.37. So, which is in quadrant 3. So that's my quadrant 3 answer, and this was my quadrant 2 answer. So again, it goes back to just a reminder, it's good to keep in mind what the angles are approximately as decimals. Pi over 2 is about 1.57. Pi, of course, is 3.14 about. 3 pi over 2 is about 4.7. So just keeping that in mind. So when you see an angle on your calculator in decimal form, you know where that is landing. Again, this will make a lot of light bulbs will go off when we, in the next unit, talk specifically about inverse trig and why our calculator is giving us certain quadrant answers. Okay, that's it.